Hi there. Today we are going to talk about the stack data structure. A stack is an access control data structure that follows the last in first out principle. It has a top index pointer that points to the top of the stack. You can think of it as a number of boxes stacked on top of each other. Box 1 goes in first and it makes the bottom of the stack, while box 4, which is added last, makes the top of the stack. The two methods associated with stack are push and pop. The push method adds the element to the stack, while the pop method removes the element from the stack. Since we are used to viewing the array as this horizontal set of boxes, many of us find it hard to realize at first how the top index would work in a horizontal set of boxes. So let us build an intuition towards an array-based stack through an animation. Here we have an array bounded stack of size 4, and as you remember, the two methods are push and pop. Initially, when the stack is empty, our top index would be at -1. When we push the first element into the stack, it would be added at index 0. The top index would now be updated to point to that first index, that is index 0. Let's push another element. 2 will be added at index 1 and the top index would be updated. Push the third element and then the top index would move to point at index 2. Let's remove a couple of elements now from our stack. Once we call the pop method, it looks for the top of the stack using the top index and then removes that element. The top index value is decremented and now it points to the preceding element in the stack. Call pop again and the top element is once again removed and the top index is decremented. As you might notice, an array bounded stack gives rise to two edge cases. What if you try to pop off an element of an empty stack? Or what if you try to push an element onto a stack that's already full? Let's head over to our IDE and start creating the array bounded stack class. Let's create an integer array stack in Java. So here, as you see, we have set a default capacity which I've set to 15 and create an integer array called elements. The top index is set to -1. As we discussed in the beginning, as the stack is empty, the top index would be at -1. First of all, let's create a default constructor. Which simply sets elements to the default capacity. Now let's create a custom constructor. Which takes in a value for the size of the elements array. As we discussed briefly the edge cases before, we want to see if the stack is full or in case the stack is empty. So for these, to check if the stack is full or empty, we are going to create two methods. First of all, let's create our isEmpty method. The isEmpty method simply returns if our top index is -1. If our top index is -1, it implies that the stack is empty. Thus, the isEmpty will return true. Similarly, I keep typing in void. Let's create a isFull method. To check if the stack is full, we can understand it this way. that if the top index pointer is at the last index of the array, it means that the stack is full. So what we could do is to return if the top index do elements of length -1. This will return whether the top index is now at the last index of our array stack. If it is, it will return true, and we'll know that the stack is full. Let's move on to our push method now. Public void push. The parameters will include the element that we want to add in. When we want to push an element into the stack, first of all, we want to check if the stack is full. We can check it this way. Simply call our method that we created full. If it is full, let's throw an exception. A stack overflow error. If it's not full, what we'll do is we'll increment the top index, and then at the top index position we'll add the new element. As you recall, the top index, which was -1, would now increment and become 0, and the 0 index of the elements array will have the new element to be added. It will store the new element that we passed in here. So simply this is our push method. Now let's create our pop method now. Just a note that this pop method simply removes the top element. To return the top element, we'll create another method called top. So when we want to remove an element, we want to check first that the stack is not empty. So we can see if the stack is empty, throw an error. The empty stack exception. All right. If it's not empty, what we do is we set the top element to be null and the top index is decremented. This makes up our pop method. To get the value of the top of the stack, we'll create a top method, which will return an integer. First of all, we'll check if the stack is empty. Throw an empty stack exception. If that's not the case, return elements top index. So that completes our class for the array bounded stack. I hope you found the explanation helpful, and don't forget to subscribe, and I'll see you in the next video.